Welcome to my part 2 video on factoring quadratics. If you have not watched part 1 yet, I highly recommend you do so because I am not going to be spending as much time on the basics for part 2 because the majority of things are the same. The only things that are different here is whatever value we have for A, it is not going to be 1, it's going to be something else. And there's going to be an extra step at the end of our diamond method for handling the fact that A is not 1. So if you haven't watched part 1, check that out first, and then I'll see you back here. If you have watched part 1, let's not waste any time and get right into it. For our first example here, we have 3x squared minus 2x minus 8. This is still in the same format as before of ax squared plus bx plus c. But as we see, a is no longer 1, a now has a different value. It could be negative, it could be positive, it could even be fractions or decimals, but I'm not going to be throwing anything of that sort at you right now. So everything is the same until the very end here. We have our diamond method. The top is still a times c, the bottom is still b. Nothing has changed. In this example, a is 3, b is negative 2, and c is negative 8. So we'll start off filling in the top and bottom of our x. A times c gives me a negative 24, and b is a negative 2. So I need to find two numbers that multiply to negative 24 and add to a negative 2. If we need to, we can create our list of factors. I've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Only one of these, when we make some of them negative and some of them positive, will multiply to negative 24, but add to a negative 2. And that choice is going to be from 4 and 6. I need a negative 6 and a positive 4. Negative 6 times a positive 4 is a negative 24, and adding them together gives us a negative 2. So, just like we did in the last problems, we have, or in the last part, 1, we have x minus 6 and x plus 4. And this is where we stopped earlier. But we don't get to stop now. And the reason for that is this is not our final answer. If I were to FOIL this out, I'm not going to get the original answer. I'm going to get something else. So this is where the new step comes in. You know how a was 3? Now that we're at this part, I need to divide by the original a. So I have 8 minus 6 divided by 3. Sorry, not 8, x. X minus 6 divided by 3 times x plus 4 divided by 3. And this is going to follow a little rule. If you can do the division, you should do the division. So x minus 6 divided by 3 is going to turn into x minus 2, because 6 divided by 3 is 2. If you can't do the division, like here, we've got 4 divided by 3, that's not going to give us a whole number, that's going to give us a decimal. You need to simplify this fraction if you can. We can't. And then take the 3 and put it in front of the x. So this becomes 3x plus 4. And this is our answer. This is what we want in the end. And just to prove it, let's FOIL it out just to make sure. So I have x minus 2 times 3x plus 4. X times 3x is 3x squared. x times 4 is a plus 4x. Negative 2 times 3 is a negative 6x. And negative 2 times 4 is a negative 8. Combine these to get a negative 2x, and everything else falls into place. And this matches that. So there we have it, a way to use the diamond method for values of a that are not 1. Let's try a couple more examples of these as we get used to dividing these by the value of a. Here we have 6x squared plus 11x plus 3, and we're going to use our diamond method again. Hopefully, if you've watched part 1 and practiced these a little bit already, you have a pretty good understanding of the diamond method. So why don't you pause the video and give it a shot. Try taking it all the way up to the point where you create your 2 parentheses, and then go from there. All right, well, A, B, and C are 3 pieces of our puzzle here. A is 6, B is 11, and C is 3. So we need 2 numbers. Oh, sorry, let's not get ahead of ourselves. A times C up top is 18, B is 11, and I need to come up with 2 numbers that are going to multiply to 18 and add to 11. Hopefully we know our factors well enough to say it's 2 and 9. So I have x plus 2 and x plus 9. Now, since a was not 1, I have to do some division. I have to divide 2 by 6 and 9 by 6. Neither of these divide evenly. So I need to simplify the fraction. 2/6 turns into 1 over 3. 9/6 turns into, oops, I don't want equals, 3 over 2. Then we take the denominator and we slide it up next to the x. So let's recap here. We found out the 2 numbers that multiply to 18, which was 2 and 9. They also added to 11. We put them into our parentheses, and then we divided by a. That's key here. Since 2 divided by 6 is a decimal and 9 divided by 6 is a decimal, we simplify the fractions we created from the division, and then we take our denominators and we slide them up next to the x. So our final answer becomes 3x plus 1 times 2x plus 3. And that is our solution. Getting the hang of it? Hope so. Once you get used to it, it's not bad, and it's a pretty fast and efficient method. But practice makes perfect. So let's try at least one more and see how we do. Here we have 4n squared minus n minus 3. If you're feeling particularly confident, pause the video and work it all the way through. Your answer, you should find, will be at the end of our tutorial. All right, A, B, and C. Ask yourself what values fill in A, B, and C. You should say A is 4, C is a negative 3, and since we have a negative n, we could think of this as a negative 1n, so B is negative 1. Create our x. A times C gives me a negative 12. B is a negative 1. And I need 2 numbers that multiply to negative 12 but add to a negative 1. Why don't you pause the video and see if you can come up with the correct combination. Did you do it? Did you come up with a -4 and a +3? If so, nice job, you got it. Now, take your -4 and 3, put them into your parentheses, and remember to use n as your variable, since these are in terms of n. I have n minus 4 and n plus 3. And what was that last part we have to do now? What's the last thing that helps us finish this? Oh, right, we have to take whatever a was and divide by a. Now, I have a -4 divided by 4. That'll give us a whole number. That'll become n minus 1. 3 divided by 4, that's going to give us a decimal. So we have to see if we can simplify this fraction, which we cannot. 3/4 is already in simplified form. So that 4 is going to slide up to the front. And we have 4n plus 3. And this is our answer. All right, and that brings us to the end of Part 2, Factoring Quadratics. Hopefully you've found some success with this diamond method. It will work for practically any factorable quadratic problem. If you can't factor it to begin with, well, or you can't factor it into something like this nicely, there's only one other method you're going to have to use, and that is the actual quadratic equation. But that's not the point of this video. Maybe we'll see that in a future video. Hope you found this helpful, and good luck!